Hello everyone and welcome to today's session on deep dive into Spark NLP. Thank you for taking time out and being here today. Apache Spark today is the most prominent framework for big data processing, along with support for out-of-box classical ML algorithms like linear models, decision tree, and lot others. On the other end, we are seeing a lot of pre-trained models and new architectures like BERT, transformers flooding the NLP space. Spark NLP is an open source NLP library unifying the state of the art models for NLP on top of Apache Spark and Spark machine learning component. To talk on Spark NLP, we have with us today Veysel Kocaman. Veysel is currently playing a role of lead data scientist with John Snow Labs. John Snow Lab is also creator of Spark NLP package. Veysel has a PhD in computer science and MS in operation research. Veysel in the past has played varied roles like CTO, head of AI, principal data scientist, and also has provided consulting services in machine learning and AI. Veysel is a frequent speaker in data science conference and workshops. Without further delay, please welcome our speaker and over to you, Veysel.
Thank you. Thank you for the invitation. It's such an honor for me to be in this event with you. So I'm really excited to share what we have been cooking at John Snow Labs for Spark NLP. So hello everyone again. So today I'm just trying to cover, like, this will be 45 or 60-minute talk. We had a big release last week, which is we upgraded all our libraries to Spark 3.1. So Spark NLP is an open source NLP library on top of Apache Spark. I think most of you already know this. It's the only NLP library in Spark. So Spark NLP has 3 different versions actually, which is created by John Snow Labs. I'm going to talk about the open source version. We already have some Spark NLP for healthcare. Maybe most of you already know my post on LinkedIn about the healthcare components. It is basically extending everything in Spark NLP, like all the NLP components. On top of that, we are adding some healthcare specific components like assertion status, entity resolution, just for the terminologies in healthcare. So we started to develop this library in October 2017, and then since then we are trying to release new version every 2 weeks. So we have an active release cycle, which is very demanding. We are adding new features every day, like every week. We, as a member of Spark NLP community and John Snow Labs employee, we even have a hard time to keep up with all these releases. So we try to make it simply, make all this NLP pre-processing or text processing in Spark as simple as possible, because Spark has its some own issues due to some dependency on JVM, and people might complain about setting it up properly, and then like reading the errors coming from JVM might cause some headaches. Yeah, I get it, because this is Spark. But when you install it, like when you set it up once, everything should be really fluent. And at John Snow Labs, while developing the Spark, we try to make this as simple as possible, even for non-Spark users. That's why we also have NLU library, which is just like pip install NLU. That NLU library is a pure Python wrapper for Spark NLP. So everything I'm going to talk about today can also be done without even using any PySpark command. So right now, just on PyPy, because Spark NLP can be supported in 4 different languages. Scala, because it's the language that we wrote this library. Spark NLP is written in Scala, and then we have a Python wrapper, like you can just install with pip Spark NLP, like pip install Spark NLP. We have a wrapper for R, which is maintained by another community member, and we also have the Java. So we can say that Spark NLP can run in Scala, Python, Java, and R, which is good for which is the well-known languages in data science, right? So in just PyPy, we have around daily 20K downloads and monthly over 600K. So right now we are around 4.5 million downloads, and we are getting the traction every day. So In Spark NLP, maybe you remember this kind of pre-trained pipelines. Like after the transfer learning era, we started to use just plug and play models in NLP. And in Spark NLP, we have some pre-trained models and pipelines that you can use just plug and play. So on the right-hand side, you see the public models, like the open source models. Like these are the ones that I'm going to talk today. On the left-hand side, it is the healthcare edition that I'm not going to cover, but you can find so many examples over there. So in Spark NLP, we try to basically cover every NLP task that you might need while working on any text processing job. So as you all know, if you are trying to process some text data, and then if you end up with some spelling errors, you might need to find the best spell checker from other libraries and then try to integrate into your pipeline. Then you found out that the word embeddings or the BERT transformer is not as good as in the library that you are using, so you try to find out another library so that you inject some other modules from other libraries. So you keep pip install and then restart again and again. But in Spark, since you need to stay in the Spark ecosystem most of the time, because Spark is for the big data, it's an in-memory computation engine. So the things that you run on your local machine, like the pipeline that you build, should work on a cluster, right? So if you need to use any other module like a Spicy or CoreNLP or Hugging Face in your code, when you try to distribute this over the cluster, it will not work, of course. Or you need to do many other settings. So the goal here is to creating the pipeline that could run on a single machine on a small data, could also run on a big data over the cluster. So that was the purpose. So that's why we try to cover all the minor and major NLP tasks in Spark NLP. As you can see, we covered all of them, almost all of them. Of course, there are some of them like the text summarization, text generation. We are working on at the moment, by the way. Another purpose was to integrate into the latest, implementing the latest papers and then making them like a production-ready models. Let's say that, for example, last week we have been working on some OCR modules to integrate into Spark NLP, and then we found out a paper, and then we work on that paper, and then try to implement the same algorithm inside Spark NLP. By the way, every deep learning algorithm, every deep learning component that we have in Spark NLP is based on TensorFlow. Right now we are on version 3, and for the TensorFlow we are using TensorFlow 2.4. So anything that is running as a deep learning component in Spark NLP is coming from TensorFlow, but you don't need a TensorFlow in your environment, by the way, because it's coming when you pip install Spark NLP and then start your Spark system. It's already inside the Spark right now. So we basically try to implement these latest papers into for the Spark users so that they can use the latest trends into Spark ecosystem as well. There are some recent surveys, which NLP libraries most of the time used in the industry. By the way, right now, as you might know, my company is also organizing that Spark NLP, like NLP Healthcare Summit right now, which I will have another talk in one hour. There are some surveys that we do every 6 months, and then Spark NLP is right now the most widely used NLP library in industry, because these are the companies that we work together and we help them. For the official supported runtimes, like any instance, any runtime that Spark can run, Spark NLP can run, because this is just another jar package that you import into your environment. Like if you are using this in Databricks, for example, on your cluster settings, you will just pull the Spark NLP jar through Maven coordinates or just pip install, and then you will get to run it with no issues. On our workshop repo, we have some notebooks as well. By the way, maybe I can do some a few minutes wrapping your head around Spark NLP ecosystem. I can show the website as well. So we are supported on EMR, Cloudera, Databricks, etc. So before jumping into our pipeline concept, maybe I can talk about how you can find the models, pre-trained models that you would need. Like TensorFlow Hub, Hugging Face Models Hub. We also have a Models Hub. When you go to nlp.johnsonowless.com, we have a models here. When you click on the models, And when you want to find out some models, let's say NER, and then let's select healthcare, because we have the healthcare version as well as open source version. When you do this, you will see all these NER models here. Okay, because I just wrote any, let me write. I just wrote like NER, name identity recognition, and then there are some model cards. So when you click on any model card, you will see the pre-trained NER model that you can use with just this line of codes. Like you use the you select one embeddings that this NER is trained on, and then you select the NER model itself, and then you fit on your, like you transform your sample text, and then it will extract all these entities in one run, in one single model. So we have today I'm going to go over the workshop repo, like one Colab notebook. Why do we do this on Colab? Because you don't need to install anything else. So everything can be installed in just one liner. We have a workshop repo which is called Spark NLP workshop under John Snow Labs. When you go there, you will see the tutorials. Right now I'm going to talk about 1 hour workshop. So this is the notebook that I'm going over right now. So you will have you have the access as well. If you go back to the tutorials and then certification trainings, you will see some gem here. Like let's click on public. You see like starting Spark NLP from scratch. All you need is here. So you can just start from the first notebook and then the second notebook, third notebook. Like we try to prepare these notebooks to teach anyone Spark and Spark NLP with just simple Spark, like PySpark experience. You can just start into Spark NLP. If you don't know, there are many resources, as well as this channel. This YouTube channel also has many cool resources for Spark. You can just jump into Spark NLP with the first notebook, and then all can run on Colab. So let's go back and then start with start running some code. At first, I want to explain how this pipeline concept works, because all Spark users already know this pipeline concept, I guess. But for the ones that have no idea or has no experience with this, it's like building the components, like putting your models over the shelf and connecting them one by one and then feed, so that you don't need to create the same pipeline again and again. And especially in Spark environment, it's very important, because in Spark ecosystem, you know, there are some eager evaluation, laser evaluation, so that you don't want to run the same pipeline again and again. Or when you run and do some like fit and then transform, it will not run end to end, you know, because it will just run after some eager functions like show, collect, etc. So that's why it's very important to know that you build your pipeline once. Or let's say that you want to end up with some word embeddings per token. You have some text. Now you want to build some text classification just in Spark NLP or Spark. So what you can do is you take the text column here, right? Let's say you have thousands of TXT files on your local. So you can just read it with read whole text file. You can, you know, in Spark, you can read the entire folder, and then each TXT file can be one row in your data frame. So you will have text column. Now you want to build some text classification based on the label per row, right? Like maybe each document represent one document class, or each sentence would represent one category. Now you want to build some classification. What you need to do is maybe you want to apply some text preprocessing, like you want to clean your text, tokenize or lemmatize. Maybe you want to get rid of some stop words. And then at the end, like the core tokens would get some embeddings, and then you want to feed this to some classifier like logistic regression, random forest, etc. All in Spark environment. Or just taking your text, feeding into sentence embeddings, word sentence embeddings, or universal sentence embeddings. As you know, when you are using sentence-wise or context-aware embeddings like universal sentence encoders or BERT or Elmo, we don't suggest doing this kind of cleanings on your text. Like you don't need to normalize your tokens, because these are all context-aware and sentence-wise embeddings. So what you need, let's talk about simple, like a classic NLP pipeline, that you take your document, get your sentences, So at first, we feed into the document assembler. This is the gateway to the Spark NLP pipeline, which means that it's going to create some annotation, some metadata, so that the rest of the components can rely on while doing some pre-processing. So when you do some sentence detection, it's going to run on the document column. So whenever it passes through one component, it's going to add there will be a new column generated right next to that. So you get the tokens from the sentence, you get the normalization from tokens. So as you can see, we are connecting the output of one annotator as an input to the another annotator, so that we build some serial pipeline. Of course, you can make it more ugly and rich. Of course, you can use, for example, you can connect the document to another tokenizer or another sentence detector in the same pipeline if you are doing two things at the same time. But we don't suggest it, of course, but you can do this. I remember building some pipelines like with 20 different components at the same time. So we feed them one by one. We say that, okay, text column will become document after document assembler, and then the document will feed to sentence detector, and then we will have the sentences. For the sentence detection, we have two different algorithms, like the pragmatic version, which is kind of rule-based, and then DL version, deep learning-based one. Most of the time we try to use a deep learning version because it's a trained model based on like which character could be an end of line or not. So, after OCR, or if you scrap some data, there is some corruption in your text that when you apply some splitting sentence boundary detection, you end up with garbage, like your end of line might corrupt your text. Especially when you extract some text from tables or PDFs, there will be some layout issues. So we tried to train and sentence detector DL model to cover these cases, these edge cases, so that you could end up with the right sentence boundaries. Why this is important? Because the model that we like, NER model, let's say, name identity recognition, or translation, or language detection. So if you feed the most informative part, they do better, right? If you train the NER model with sentences, which we usually do, because it's a token classification, we feed one sentence at a time, right? So if you feed entire document, the model may not be able to, because it's running on by LSTM, so it may not find the long dependencies. So that's why you need to know you have the right sentence boundaries. The next one is tokenizer. So tokenizers for the NER, let's just talk about NER again. In NER, name identity recognition, we try to assign some labels to each tokens, right? So that's why tokenization is also matters a lot for the NER purposes, because if you feed some tokens to your NER algorithm and there is no embeddings for that token, so you would end up with minimal information like casing features, etc. Anyway, so we feed one by one. After token, we clean some, like, let's say, just drop the punctuations and the digits. We can use normalizer, and then now we fit this to word embeddings. So you can select word embeddings, Elmo embeddings. I'm going to cover them as well. So at the end, we feed and then transform. Now I can move this pipeline to anywhere, and then I can even run the same pipeline over cluster. Okay, so before building this kind of pipelines, let's just talk about pre-trained pipeline that we built from scratch and then uploaded to S3 on AWS, so that you can just plug and play. So we have some pre-trained pipelines that you can use, which is already combination of certain annotators, certain modules in the same pipeline. So let's at first start the Spark session. I'm going to try to do live coding as much as possible if time allows. So we have one single line to set up the Spark NLP library. We also have Spark NLP display library. Let me run this at first, and then I will keep talking about this. So we have a bash script to prepare your environment for Spark and Spark NLP. Right now the session is connected. Now everything is being installed. We are going to use Spark 3. Okay, Spark NLP 3.01. This is the version that we are running right now, and it is depending on the Spark 3.1.1. So the only thing that is going to be installed with Spark NLP is this library. We also have Spark NLP display. It's one of our simple libraries, like as a utility library that we use sometimes to visualize something. It's like a display scene spicy. but it's we are doing some visualization for the NER, for the dependency parser, for the relation extraction. So we fit the annotation from Spark NLP pipeline and end up with some nice colored boxes. So when I run this bash script, it's going to prepare my environment for Sparks. So because we get too many complaints from the people that they are not able to install Spark properly on their system. So on Colab, it's just one line. On your local, you can just click on this bash script because it's already coming from open source library. This is our own library, right? So you can just go there and then check the steps that we implemented over there. So you can just mimic the same and then try to have the same on your local. Especially we have some blog posts for installation on Windows, MacOS, and Linux systems. So you can just Google it, like Spark NLP installation, which I personally wrote. You can find those informations as well. We also have some blog posts about how to set Spark NLP on Databricks. We have tons of information on our release notes and website, so you can find them if you start. Or we have a live active Slack channel that we try to help every day. You can just join. So you can find this here. Like when you click on this on our website, you can find you can join our Slack channel. So it's gonna take a few minutes to set up everything because it's going to install that, like as you see, Hadoop, etc. The session, everything is coming right now, and then JDK. It's orange right now. Orange means the session is ready. So we have the Spark and PySpark installed. Now we are going to start the session. Starting the session, like Spark users know that like everything happens inside the Spark session, right? So we need to start the session with Spark session command coming from PySpark itself. But we have a wrapper for this. SparkNLP.start is doing something on the backend that is like pulling some jars from the Maven coordinates and then starting the session with default parameters. So like a default 16 gig driver memory and some Kairos serializer settings, etc. If you are not satisfied with this, you can definitely go back to, like on the first notebook, I try to cover this. Like you remember this notebook, like a first notebook on the other tab. So what it is doing is it's basically doing like this. When you run start, this is what happens on the backend actually. So it's pulling some, given the parameters, because we also have the GPU version. Okay, like if you want to do some GPU related, like if you want to train your model on GPU, you can also set this to true when you just start. Like here, you can just write GPU, right? GPU true, and then you can start your session with GPU jars. So here, it's also setting some driver memory, some other settings that any Spark session would need. But to hide the ugly part, you can just run this. Okay, so I'm not going to use the GPU part, it's already there. What I'm going to do at first is just download one single pre-trained pipeline and then transform my text without writing any pipeline, because I want to start with the pre-trained pipeline at first and then building a pipeline from scratch, which we are going to build some spell checking pipeline from scratch. Today, I will also try to cover how you can do some text preprocessing in Spark NLP and then use Spark ML, random forest or GBT or logistic regression. Because in Spark NLP, we don't have logistic regression or random forest because they are already coming from Spark ML. So we don't need to rewrite them from scratch, right? So you can even get the BERT embeddings in Spark NLP and feed this BERT embeddings to logistic regression in Spark ML, which I'm going to show. So right now, when I do this, you have this is a one pipeline that is pulled from S3 right now that we already uploaded for you. So it's 170 megabytes. So now if you see its stages, right, it has like 8 different stages right now already saved with this pipeline. So what it's going to do is it will take the document text, get the sentences and then the tokens, and each token will get embeddings from Glow 100 embeddings. This is a default one that we use, but we have many other embeddings that I'm going to cover. Then every token will get the lemma version and stem version, and then we will have the part of speech tag. To make it slim, we also have some spell checkers. We have two different spell checkers in Spark NLP. DL version, which is context aware, and rule-based one, which is not the rule-based, but statistical one, which is by Nordic Approach. So let's see the Nordic Approach at first, like end-to-end. So I just added some simple sentences here, which is one single doc. As you might remember from Spark, you need to use RDD or Spark data frame, right? But what we are going to do here is I'm going to show you something that is getting rid of the overhead of Spark itself, which is still Spark, but instead of creating some data frame, I'm going to show you something that you can apply on string. So when you run this, it's called .annotate. This is the one that we pulled here, right? Which we assigned here. Now I'm going to annotate my string text. This could be a list of string as well. So .annotate means that running light pipelines. There is a light pipeline concept in Spark NLP, which is really good for experimentation with small data. We also use this light pipeline concept to deploy our models through Flask or Streamlit for demo purposes. Or if you are going to fire up some like a runtime API and then predict and then serve your customers as a toy project, or maybe just to see how it is received by the customer. So you can just deploy an app with this light pipeline so that any string that is fed through API can be processed much faster than using that Spark DF. Because in Spark DF, you need when you create a Spark data frame, there's some default parallelism, etc. So there's some overhead coming from Spark itself. So right now we are pulling everything on the one single machine with this .annotate. Of course, we can also, instead of this one, if you write transform, you can also feed some df here. Okay, but we are not. I'm just going to show you how to do this on a string. So when I do this, it's going to return a dictionary with all the results coming from these steps, these stages. So which means that it's a dictionary, and so every token will get stem, and every stem will get lemma, etc. So let's just print out as you can see, these are the attributes that I just extracted from each step. So stem comes from stemmer, checked comes from spell checker, lemma comes from lemmatizer. So let's print out the entities because it has a slim entities inside, right? So it is an CoNNL 2003 NER model, which is already there, trained with Glow 100 dimension embeddings. So it's going to return these embeddings. So let's convert this to the pandas to print out like token versus NER label versus spelling corrected tokens. As you can see, I just converted this dictionary to a Spark data frame that you can see token per NER label per each token has a spell corrected version, etc. As you can see, I added some typos here to see if Norvik could fix it. As you can see, it's fixed here. So there's also another typo here, and it's also fixed. And the lemma is the the getting rid of the inflectional form of each token. So okay, so let's do, if you want to get more information from this annotation, because right now we don't have the borders, right? But most of the time you want to know that which token starts from which indices and what are the sentence boundaries, so that you can use this information to visualize something or feed some downstream tasks. So let's do like this. So we have a full annotate command, which is coming from Spark NLP. So you feed your text with full annotate. So right now you have the entities with all these metadata. So Peter Parker is a person entity, starting with 1 and 12, ending with 12. It is the first sentence and first chunk. So Europe is a location entity. It lives in fifth sentence. Of course, sixth sentence, and then the sixth chunk. Okay, so you can create a data frame again, like a pandas data frame. Why am I doing this? Because people want to work with something that are very familiar with them, right? Like, for example, you want to get the embeddings from Spark NLP. or get the NER labels from Spark NLP, and then create some CSV, and then use this in another notebook or another pipeline. So that's why I always try to, during the workshops, I always try to convert the outputs to pandas, because to show that this is something that you can use very simple Python scripts. Okay, so we have the chunks and then the entities. So let's do the same with all these indices, right? When you do this, you have the sentence IDs, token. By the way, when I am entering any cell, it's a live code right now, it's running, so you can implement the same. Maybe we can rewatch this and then implement the same at your own pace. So we have the sentences. This is the first sentence, like till here, like this. And we have the tokens from each, and then we have all the other attributes that we would need. So let's do more interesting and cool stuff. So what if we want to create this pipeline from scratch? So I'm going to show how you can do this with Spellchecker DL version. So Spellchecker DL is it's a context spell checker, which is fixing the typos given the context. Let's talk about, let's see the example here. For example, if like during the summer, we have the best weather or ladder here. So as a human, when I see this, it should be weather, right? So I have a black leather jacket, so, or weather jacket, right? So given the context, it suggests it should be like leather, right? So in Nordic or the statistical approaches, it just look at the token itself. So because it tries to find the added distances, if this token is one of the words in the Nordic approach, like because Nordic approach is trained on some large novels or text data sets, it's an unsupervised, of course, it tries to find what's the possibility of this word to becoming weather or ladder or header as a human name. But in context spell checker, we train the model with entire context, like sentence by sentence, because it's easy to create a corrupted sentence from a correct sentence, right? You can randomly add some. We have some blog posts about this, by the way, how you can train a spell checker from scratch. Just Google it, contextual spell checker, and Spark NLP. You will see some nice articles, which is written by the author of this model. The author of this model is one of my colleagues. So the goal is here to fix this typos given the context, which is called context spell checker. So let's create a pipeline from scratch. At first, we feed the document assembler because this is the gateway to every Spark NLP pipeline. So we feed this, and then we apply some tokenizer for this token, because the model is trained with token by token with the entire sequence. So we fit this, and then this could be. By the way, you can also add sentence detector here, right? Sometimes you may not need the sentences. Maybe your documents are short. Maybe they are already sentenced. So you can also add the sentence detector here. Now I connected the output of document assembler to the tokenizer, and then the tokenizer to the context spell checker, which is a pre-trained model. And then I'm adding with finisher. Why finisher? Because as you can see, every annotator will add new column names, like a token column, lemma column, spell check column, etc. What if you want to get rid of everything and you just want to end up with this correct version of each token? So that's why we have the finisher that is get rid of everything. So it says that just use the check column and get rid of token and document column. So we run this and then fit on an empty pipeline, like empty text. Why do we do this? Because when you fit this, when you build this pipeline comes from PySpark.ml. Okay, this pipeline. This is not Spark for NLP, but every annotator in Spark NLP can be used in PySpark pipeline and vice versa. So right now I am building a pipeline, Spark ML pipeline, with everything coming from Spark NLP. So when I do this, it's just a list right now. So I need to fit it to become a pipeline model. It's like a scalar, right? Like when you do some scaling or TF-IDF vectorization, what you need to do is you at first fit and then transform on your text set, right? So here you need to fit on something, but there is nothing to train here, right? Because they are already trained. So you can just fit on empty data frame to make this pipeline a pipeline model. So right now we have the pipeline model after fitting, right? Empty DF, I just fit it on the empty DF. Now I have spell pipeline model. So when I just write this, right? Let's just print this out. You will see that this is a pipeline model, right? So this is a pipeline model. Pipeline model is also PySpark ML. So we have the stages inside, like the stages that I put while training. Now I can save this to my disk, ship to somewhere else, other instance, or say my local and then use in my API by loading. So let's save this. I'm saving this. When it is saved, as you can see, it will be on my local disk. So you can save it to anywhere. By the way, when you do, let me show you something while it's being saved. When I do pretrained with any Spark NLP annotator, this is going to be pulled from S3. So where do they saved, right? So it's on your home folder. In Colab, it's root folder. When you go here, you will see the root folder. There is a cache pretrained folder created by Spark NLP when you try to do some pretrained, like pull some pretrained models. You see, we used explained document DL before. Now spell check DL also downloaded from S3, so it's here. So you can, instead of that pretrained, which means that as long as you have this your local, you can just do load, right? And then give the full path here, or local path. So that pretrained basically tells Spark NLP resource downloader that check this model in S3. If the one that in your cache pretrained is same as the one in S3, do not do anything. So if you have an outdated model on your local, pull the latest one from S3. So that way you always make sure that you have the latest version, because we sometimes update these models and then like to retrain and update and then re-upload, so that you may not notice that we have an updated model out there. Okay, so now it's downloaded, like it's saved to my disk. Let's just print this out and then see. You see, it's saved. Now you can load from disk. Okay, you can load from disk and now run on your pipeline, run on your text. So this is going to, when it's loaded into your memory, it's going to be in your memory. From now on, you can just run this on any text with that annotate or any data frame with that transform. So it's done. So let's run this. It's finished. So let's check its fixed version. You see, we have the best weather. So this one is fixed as weather. The other sentences, I have a black ladder. It's also fixed very well, right? If you had fed this to Nordic spell checker, you would probably end up with something else. So actually, we can do this. Let's do this. So let's delete this and add this, right? And you see, this is also fixed by Nordic. Nordic also caught this, but this one is also ladder by Nordic. This should be ladder. So that's, which means that DL version of spell checker fixed this one very well, but Nordic couldn't because it didn't see the entire sentence. Okay, so let's skip to next topic. Since we are running out of time, maybe I can skip the basic NLP stuff like text matcher. Like the text matcher is if you want to extract some known chunks. Let's say that you want to extract some financial terms like this, or sport-related terms, this. So you can write this to local. Why local? Because this should be broadcasted, right, on Spark cluster. So that's why it needs to be written somewhere and then feed it into your pipeline. And then your pipeline, we have a text matcher for this. Will text matcher will get some list from local file, and then you can feed this pipeline. And at the end, when you feed this on, when you transform on this some data frame. Okay, let's read the data frame at first. So we have a data frame right now. I just download somewhere as a CSV, and now I have the Spark DF. Now I can just run this here and then end up with some pipeline model, because let's run this at first. This one. Now I can transform. Well, now the transformation is done. In Spark, when you do transform, there's nothing happened yet, because there needs to be some eager function called for this. So like take, collect, etc. So you can just print this, and then you will end up with like filtering. You will end up with some financial terms, support terms. Let's jump to the more exciting part, actually. Assume that you have a pipeline. Now we have the pipeline, right? We have the pipeline here, but I still want to, but right now you cannot use with strings, because this is a pipeline itself, not the pre-trained pipeline from Spark NLP. Now you need to put this into light pipeline. Light pipeline is coming from Spark NLP. So any pipeline that is just built by Spark NLP components can be fitted into light pipeline. If there would be some Spark ML component in this pipeline, you wouldn't use light pipeline, of course, because this is something that we do with our own annotators. So when you put your pipeline model into light pipeline, now you can use any string instead of data frame. Other than, of course, you can use data frame. So for the other languages, we also have language detection. We have the text generation. We even have the T5, by the way. Okay, like question answering or text generation. So let's jump into the embeddings part. In embeddings, we have, let me show you the embeddings that we have. These are the embeddings that we have right now, like word embeddings, classic ones, BERT embeddings. Even we have the Electra, BioBERT version, clinical version, COVID BERT, small BERT, like all the embeddings that you can see on Hugging Face. So we have we are pulling all these, of course, embeddings from TFUp, right? And then we have our own annotator, BERT embeddings annotator or BERT sentence embeddings annotator, and then try to get them run into our annotator so that you can use these transformers in Spark environment. So how do we call it? For the Glow versions, we use word embeddings model annotator. When you call this, it's going to be pulled here. If you want to do BERT embeddings, we have a BERT embeddings annotator. When you call it, it's going to be pulled from S3. So sentence embeddings, we have some small BERT, sentence BERT, right? Let's say you have some embeddings in PyTorch. You can also use Onyx to convert to TF, TensorFlow, right? And then we have some notebooks to show you how you can use your own embeddings inside Spark NLP, so that you don't, because so far till Spark NLP, people that are who are all relying on Spark or Scala had no choice other than Spark ML, right? Well, they try to train some models with the latest deep learning algorithms. Right now, Spark NLP opens the door for all the other possibilities in transformer era. So you can just call this and then feed it into your, transform your document with this embeddings and then feed it into logistic regression annotator in Spark ML. Or we have classifier DL annotator. Let me show you the classifier DL version. So another thing, let's talk about universal sentence encoder. This is another sentence-wise encoder, developed by Google, so that it can create the embeddings per sentence. So at the end, you end up with this, you feed your sentence and you end up with embeddings. I think you already know what embeddings are, so I can just skip this part. And the goal here is that feeding your text, getting the embeddings, and feeding this to some deep learning or machine learning algorithm. Even in Spark ML, even in Scala, because when you have this, you can just save this to convert this to pandas, right? And then use it in our Scala pipelines. So let's talk about NER, which is the one of the we call this NER as our flagship component in Spark NLP, because we published some papers about NER, 3 different papers. We have benchmarks on papers with code.com, so you can also check. They are mainly clinical, but the algorithm used in the clinical version is exactly the same in the open source, which means that you can train your own NER model using the same CoNNL dataset. And then you have your own NER model, like custom NER model. We have some pre-trained ones, trained on CoNNL 2003 and Onto datasets. So you can just use it as it is, that like that pre-trained, and you will have it on your local. So I have some benchmarks here that you can check later on if you want. But on the like a competition rankings, like for the CoNNL 2003, the highest score is like 93.5. So when you check, we have this one by using, this is our algorithm in the RDL approach, we call it, and this is the embeddings. So in Spark NLP, when you train an NER model, in NER means that assign labels for each token, right? You and for in BiLSTM, CNN, char architecture is the one that we are using in Spark NLP. Of course, there are some CRF version as well. We also have this CRF in Spark NLP. So it's kind of getting 3 different features for each token. 3 different features are embeddings feature for each token, casing features like uppercase, lowercase, because it's a nice indication of if this token is location or person name, right? And the last feature is char features, like a character by like letter by letter. So this orange box represents that algorithm, and then you can select any embeddings that you can run this one. So if you want to use bird and then BiLSTM CNN, of course it would work. You can use Elmo, you can use Glow, you can use your own embeddings that you train with Jensen. Okay, so it could work. So I have some benchmarks here. Let's skip that. This is the Onto NER. You know, this is the second most well-known embeddings out there, sorry, NER models out there. It has 18 different entities that you can use. We have different versions of them. The trick here is if you want to use some NER model from our libraries, so how do you know that which NER do we have? So let's go back to Models Hub, right? Click on Models, right Onto. Okay, these are the embeddings. These are the NER models that we have, right? So we have Onto 300, Onto 100. Let's say you want to use the 300 version. 300 is the dimension, by the way. So you will see some code sample here. It says that use this embeddings to use this NER model. Because this is the NER model itself is just 14 megabyte, right? This is a trained checkpoints from TensorFlow. So, but it needs the embeddings as well to get the prediction. It's like the feature that you used while training your model, which you would need to create again while applying on your test data, right? Because you need to have all these features ready for the test data as well. So it basically, we ship them one by one. Like we ship NER and embeddings as 2 separate annotators, so that you know that when you want to use this, you need this one. How do you know that which one is required? The first thing, you can check Models Hub. Other thing, when you just pull this up and then check get storage ref, NERDL model dot get storage ref, you will see which embeddings it's trained on. By the way, everything right now, I am fast. I know. I'm trying to be cover as much as possible given this duration. But if you want to learn much, you can just go to Spark NLP workshop repo, and then you will see many examples here. Like just for NER, I have 1 notebook. Just for classification, I have 2 different notebooks. For keyword extraction, I have 1 notebook. Sentence detection, 1 another. Okay, you can just check them one by one to get more information. Okay, so let's train an NER model. To train an NER model, name identity recognition model. Name identity recognition is a token classification problem. Like let's download sample CoNNL 2003 dataset. As you can see, if I go to content and click on this one, actually, let's do not open it. I don't want to change the secret. It's just a TXT file with token and labels. Okay, token and labels. So I can just let's rename as TXT file so that I can open it in here. Okay, so this is token and label. Like B means that the beginning of the chunk. If like John Smith, let's say Peter Blackburn here. So Peter Blackburn is one entity, but the Peter is the first token and Blackburn is the second token. So if you prepare your data set like this, all you need to do is feed it into like read by ConnL reader coming from SparkNLP.training. By the way, our session, okay, why? Because we changed this extension, right? Couldn't find because it was different. Now I changed it. Now I have all the, let me close this to have more space. Now, when I read that txt file, I end up with all these columns already prepared because these columns may be required for the downstream NER models, right? Because we need to train an NER for, it needs to know the tokens and then the labels. In NERDL, we don't need part of speech, but if I would be using NER CRF, like a CRF output layer, so I would need the part of speech tag as well. Anyway, so you don't need to worry about it. You will read it, and then you will just select any embeddings that you want. I want to select 100D here, and then I will just call my NERDL approach. NERDL approach will try to fit the model on the data set that you have. You will say that, okay, this is my target column. This should be the output column. So it's going to give the predictions in this column name. So train one epo, and then learning rate is like this much, and then decay is this much, and batch size, etc. Okay, so you define everything that you might define in any Keras deep learning model. Okay, so we run this just one epo, like, and then you fit on your training data. Training data is this one, right? So it's going to add an embeddings column here. And then in RDL approach, we'll use the embeddings, label, token, and document columns to train a model for you. And then you will have, like after one epo, you will have a decent NER model in 3 minutes. Like in 3 minutes on ConnL 2003, you will have these metrics. Like after just one epo, in 3 minutes, we have 88% F1 score, which is really good. Okay, so you can save this. Since this is a pipeline right now, you can access its stages. Like the second stage is the NER, because the first stage, as you can see here, is the embeddings itself. After fitting, there will be an NER model created, right? So you can access it and then write your disk. And now you can use this with any other pre-trained NER model in another pipeline like this, .load. Okay, so let's cover the classification and then get some questions. So the classification, as you know, in classification, we basically feed a sentence and then use any embeddings. And then we have the vectorization of the sentences or tags. And then Spark NLP, we have 3 different classifiers. Classifier DL, sentiment DL, multi-classifier DL. So classifier DL is like around 100 different classes you can train. Multi-classifier is multi-label actually. There's a misnomer, I guess. So it should be multi-label classifier. So one sentence can have multiple labels. And sentiment DL has just 3 classes. So which is using another architecture crafted for sentiment detection. So if we have some like a neutral, positive, negative, this kind of sentiment data sets, that you can use this, we should do better than the other ones because of the architecture. The nice thing is you don't need to build this architecture from scratch. All you need to do is select fit your sentence and select any embeddings that you have, any embeddings in Spark NLP, like you can use any embeddings in our models hub, and then feed it into here. So your pipeline will have 3 stages: document embeddings, right? Like, sorry, document assembler, embeddings, and classifier DL. So by just 3 annotators, you will have a classification model. So we already have some pre-trained classification model, by the way, trained on some well-known data set like track 50, spam, fake news, emotion. So you can use them as well. So how do you use this? You can just classify DL model dot pre-trained and this one. So you can use this on your data set. Yeah, I personally know that some of the companies out there using these pre-trained models and pipelines to serve their own customers already, instead of training from scratch, because it's a good start. If you want to train a model from scratch, train a classifier from scratch, you can just have your CSV and then create some Spark data frame, right? Let's see our Spark data frame. Let me just read this and then read and then create some test data. So if you want to see what's inside, right? So in Spark, as you know, we do show, right? So you can just do show, and now we have two columns. Category is the class and description is the text itself. So we try to classify each sentences into different categories. What we do is we select document assembler. This is the gateway. This should be there. We say that, okay, this is my text column. Description is my text column. And then from now on, I will just connect the dots. So I want to use universal sentence encoder. So I can just connect the document to the sentence encoder, and then it will return sentence embedding. So you can name it any way you want, by the way. And then you will tell the classifier DL approach. Approach means it's a trainable, okay? Classifier DL model is something that is already trained that you can use. So approach is the heart of the algorithm. It's like the model, like in Keras. So you fit the sentence embeddings as an input column, and then output column will be a class, like it's a prediction. Label column, target column is category coming from this, okay? So this is a Spark data frame. So now you have some parameters here that you can see in NER, like a learning rate, EPO, etc. Okay, and then when you run this in 10 minutes, okay, since I don't have time, I'm not going to run. I'm just going to run this. When I run this, there is a log created, okay, in annotated logs in your home folder, or you can specify some path. As you can see, in 10 EPO, I have 91.3. Accuracy, since this is a perfectly balanced data set. And now in just 10 minutes, using universal sentence encoders, I have a model that I can use in anywhere. Okay, these are the metrics. So you can convert this to pandas, as I said, after getting the prediction, and then use some sklearn classification report, right? Then you can use light pipeline, put your model into light pipeline, and then get predictions from text. Okay, so, and a few other things like this one. Let's say that you want to do some text pre-processing with Spark NLP, right? These are all Spark NLP. Then using TF-IDF from Spark ML, right? Now you have the TF-IDF that you can create features on top of the tokens that you got from clean tokens from Spark ML. Now you can fit this into some logistic regression coming from Spark ML itself. I'm not going to run this. Okay. So, and then we have this metrics. So you can also do like getting the BERT embeddings from Spark NLP and then feeding into logistic regression. Okay. Like this classifier deal with BERT sentence embeddings in a small BERT or large BERT, depending on your use case. On Collab, sometimes your session might crash because we are running too many models at the same time. And last, we have the visualizer. Visualizer means Spark NLP display library. So let's say that you have the dependency parser. We have a dependency parser in Spark NLP, by the way. Okay, dependency parser. So we just connect the part of speech to this one, and at the end, it's just visualize your, like it's like a display scene, right? What if I want to visualize the NER outputs? So this is how you can visualize the NER output. Like I fit the sentences and NER, and then NER returned like this is person, this is location, etc. And then the Spark NLP display highlighted everything. Okay, so we are done. I think I can get the questions if you want. We are, I think, just 60 minutes. I think we covered. Thank you very much.
Yeah, and thank you, Veysel, for this fast intro, right? And to those who are watching, I know like it was pretty fast. The idea is basically just to give an angle of Spark NLP, how the pipeline is. And if you are aware of Spark ML pipelines, the pipelines are very similar. But what you're trying to do is you're trying to get the additional estimators and transformers from Spark NLP and trying to fit in that particular pipeline. You can go and check the repo. I'll add the repo also to this link where there are detailed code. You can just open each and everything and run it in the collab, and you can learn by yourself. But this gives an overview of what Spark NLP, what kind of pre-trained model it contains and everything. And thank you, Veysel, for covering it. I know like we had very short time. You had to rush up, but thank you for covering it. So, Veysel, I have one question which typically I ask with any Spark ML, Spark ML pipelines, right? Can the trained model, final trained model, can it be run outside of Spark context? So typically what happens, we have big data, we want to run it on Spark, and we can save the model, and then we want to run it in a non-Spark context. So is that possible with Spark NLP? Am I making sense?
So yeah, none. I can answer from the Spark NLP point of view. Like, let's say that we trained a classifier model. Right now, we have the checkpoints. Like, let me show you something. You still see my screen, I guess. So in here, we have some. You see there's some metadata here. Okay, metadata and TensorFlow checkpoints. So these are TensorFlow checkpoints. If you know what you are doing with TensorFlow, if you already know how to export these checkpoints outside of Spark NLP, actually this is the basic checkpoints that you can read with any TF graph, right? So you can use this if you want. We are working on some notebooks to export this outside of Spark NLP and vice versa. Let's say that you saw some model in TFHub, you really liked it, and you want to use it in your environment, Spark environment. So we are also preparing some notebooks to let you select any model, pick up any model from TFHub, and then use inside you. So we will have some converter in the middle. Right now, there is no one-click solution, but if you know TensorFlow, you can just open it up. You see it's a 100 megabyte checkpoints. That because it's an open source, you can just have this and then export outside, and then you can still use it. Every model that we have, deep learning model, is TensorFlow based. So if you know TensorFlow, you can do this.
Does it actually export the pipeline also when we finally save the model, or each pipeline component is a separate model that we need to import? So because now it's a multiple steps, right? You will have tokenization, you have everything. So when we export it, how does it work? Like, do we have to take the pipeline separately and the model separately, or we can export it at one shot?
You can export it, like if this is we built something here, right? Spell checker. So we created a pipeline from scratch, right? Right now we have the like 1, 2, 3, 4 different components. Now we save this after. So right now I can treat this any pipeline model. So I can just zip this and move anywhere and then load like this. This is coming from Spark ML, right? Like if you are using pre-trained pipeline from Spark NLP, you can use this command. If you want to use pipeline model.load from Spark ML, you can also do this. When you do this, you load all back these stages, which means that now you don't need to feed again because it's going to have some take some space on your disk. So you have everything. It's same happens with any NER model or classification model as well.
Got it. And you mentioned that OCR is also there as part of the pipeline, right? So is it already available or is it upcoming? Like
OCR, right? OCR you meant?
Yeah.
OCR. Yeah, OCR is, yes, Spark OCR is a license library which we sell to our customers. We have some transformers, Spark transformers for image. Let's say that you wanna add some, image binarizer. You wanna remove some background noise. So we have all this, like we have in tokenizer here, right? Like normalizer here. We have some transformers in Spark OCR that we take the PDF as an input. This is like, I can just talk about how we run the projects with the other clients. So we usually start with in healthcare domain. We usually start with some TXT files or PDFs or images, okay, and then feed it into the OCR pipeline. OCR pipeline returns some TXT files with the layout information, with all the coordinates that you can see from Tesseract, right? It will, with all work, will have its own physical coordinates. Now we fit this text into Spark pipeline. Spark pipeline, now you can treat this text as any text that you might see. So it opens the door for, by the way, we have a, let me show you the notebook. We have a notebook here, tutorials, certification trainings, healthcare, and fifth notebook. Fifth notebook here is Spark OCR notebook. It explains all the steps that we do. We feed a PDF, and at the end we text, and then we connect the dots and feed this to any RDL model. We still stay in the same ecosystem. So if this doesn't open, by the way, on GitHub there are some large notebooks. If it doesn't open, you can just in the address bar write collab, GitHub to collab. So it's gonna open in collab right after. So you can just go and then check this out as well.
Got it. Got it. There's a question from Tanya. So Tanya's question is, which classifier model does NER classifier approach use? Is there documentation specifying the model architecture used in it?
Okay, we have three classifier: document like classifier DL, sentiment DL, and multi-classifier DL. So it's just a bunch of like a pre-trained. We experimented with different architecture in TensorFlow, like adding the dropout layers and then some other DL components in the same pipeline, and then try to find out by using this benchmark data set. We came up with some DL architecture. It's not MLP. It's not just multi-layer perceptron. We use some LSTM because we developed this classifier DL just to run on the embeddings, which means that we get the embeddings representation of your text or word, and then fit this to as an input, because we need a fixed input, right? So we have the dimension. We know the dimension of the embeddings, and then fit this. Now from now on, we have some predefined architectures that I can cover maybe in another session. But you can find it into our website. There is a large network that we built. It's not, of course, state of the art, because it depends. The state of the art DL architectures depend on the data that you have. Some data set may not some architectures may not do well on your data set. So that's why you customize again and again. But right now we have three predefined architectures built on top of TensorFlow that you can use. I am not sure if I would be able to answer.
Got it. Maybe the documents at the John Snow Labs website is there. People can go and details as well. There is a message from Sapning, and thanks Veysel for the wonderful session. Looking forward to play with the notebook. Thank you for that, Veysel. I have one question from Gulab. How to train and tune BERT-like models from scratch in Spark NLP? Where and how one can get started?
Okay, so like you want to train a BERT model from scratch in Spark NLP, right? That's the question. Right. So if you select, like on this notebook, if you click on classifier DL with BERT sentence, so to train any BERT classifier in Spark NLP, this is all you need. So you don't need to do anything else. You have just text, and then you will just repeat your text here and then here. So if you want to fine tune, sometimes we do something like this. Let's say that the BERT embeddings out there needs to be fine-tuned, because we are not using the same architecture in the PyTorch, right? So what we do, this is not end-to-end training. We are using the checkpoints coming from this already pre-trained and saved. So if you want to fine-tune this, you can select any embeddings, BERT embeddings, fine-tune. We have some notebooks for that. If you reach out in Slack channel, I can share as well. You can select any BERT embeddings, fine-tune in PyTorch or TensorFlow outside of Spark. Okay, this is a usual case, by the way. We start with some embeddings, fine-tune outside of Spark, because I don't need to fine-tune it in Spark NLP, which might be like slower or not fully compatible. We fine-tune outside and then convert into Spark NLP. So we have notebooks to do this. If you Google, we did this for Portical, I guess, Portical BERT embeddings. We did this and then prepared a notebook that you can use. I think it's here. So you can go back to here, and then in Jupyter, you can find some examples here. Okay, trainings. You see, export BERT model to Spark NLP BERT embeddings. So you can have any BERT embeddings fine-tune outside on your own data set and then import in the Spark NLP. Now you have your specific BERT embeddings that you can use in your Spark environment. Okay?
Got it. So
we basically try to move everything, like we bring TensorFlow world to Spark right now. That's the goal.
Got it. So I know like a lot of people have asked like, can you please share GitHub repo? What I will do is I'll put the GitHub repo on the video link after this session is done. But it's pretty easy. You can just do GitHub John Snow Labs and then go to Spark NLP workshop, and you have like a lot of notebooks which you can play around, which cover each and every step that Vishal spoke about today in detail. You can use that, but I will add it to the link as well. There's one more question from Satwan. Can we train medical embeddings related to ICD codes using existing BERT models in Spark NLP?
So for the ICD codes, we are not using, like I would suggest, because we have entity resolvers for ICD terms, SNOMED, RxNOM, or everything. What we do is we use some sentence embeddings to represent the chunks, and then train an unsupervised clustering model in Spark NLP, which is licensed, by the way. But let's say that you want to train an embeddings for these terminologies. Of course, you can do this outside, and then you would have a UMLS BERT, right? UMLS BERT or SNOMED BERT. Now you can have this and inside Spark NLP, and then you can use inside on your pipeline. So like fine tuning right now happens outside of Spark NLP, but it can, but it's not a limitation actually, because it's as I show in the other notebooks, you can just fine tune, like fine tune any BERT for UMLS concepts or RxNOM concepts, because fine tuning means that you have the text, right? You will just fit this, because fine tuning is unsupervised in BERT. You will just fit this, and then you will have the fine tuned BERT. I think the question is same actually. If you want, you can check some clinical NLP videos on YouTube that I share sometimes. You can also just Google my name and then Spark NLP or medical, this kind of keywords, and you will see some medical use cases, how we use these models in the medical domain.
Got it. Got it.
Okay.
And thanks for the session, Veysel. I think that's the questions we have. Again, thank you very much. Thank you for taking time. I know you have one other like speaking session next, which you have to join. Thank you for your time, and there's a lot of thanks coming in from the folks out there. It was a wonderful session, and I'm sure like a lot of people the detail. And for me also, it was the first session on Spark NLP. So I will also try to go and explore Spark NLP and see how it works. Thank you very much, Veysel.
Thank you for your invitation again. It was my pleasure. I would definitely want to help you guys. If you ask any question on Slack or email or LinkedIn, I'm open to connect. So I hope you like it. Thank you very much again.
Thank you.